Good morning, ladies and gentlemen. My name is Mahya Hoseini, a PhD student of Coastal Engineering in KNTC University of Technology. I'm going to talk about long-term prediction of Caspian Sea level under CMIP6 scenarios using artificial neural networks as a part of my thesis under the supervision of Professor Mohsen Sultanpour. This study aims to examine the possibility of long-term prediction of Caspian Sea level through improving precipitation and temperature over the sea derived from AUGCMs by applying artificial neural networks. I'm going to concentrate on the following points: study area, introduction, literature review, methodology, results, and discussion. Now, let's move on to point 1. The Caspian Sea is the world's largest lake without any outlet to the sea. It locates in a semi-arid area between latitudes 36 degrees up to 47 degrees and longitudes 47 degrees up to 54 degrees. As you can see in this figure, this endorheic basin situated between Europe and Asia is surrounded by 5 countries, including Russia, Kazakhstan, Turkmenistan, Iran, and Azerbaijan. Also, this yellow area shows the drainage area of the Caspian Sea. The Caspian Sea's area is approximately about 371,000 square kilometers excluding the Karabogaz-Gol Bay, and its length from north to south is about 1,200 kilometers. The Caspian sea level is below the mean sea level of the ocean. In contrast to global sea level changes, the Caspian sea level fluctuations have occurred 100 times faster over the last century. Historical data and water level indicators reveal that the Caspian sea level has been strongly fluctuating in the past. You can see mean annual observed sea level in Makhachkala station in this figure. During 1930 to 1977, seawater level sharply fell by more than 3 meters to its lowest level in the last 400 years, that is 29 meters below the Baltic datum. During 1977 and 1995, an unexpected rise of about 2.5 meters up to 26.5 meters resulted in enormous flooding and various problems in neighboring countries. After this sharp rise, Caspian sea level was gradually decreasing with the present value of about minus 27.8 meters. The fall of water results in different kinds of problems such as navigability at ports. The overwhelming majority of scientists who studied the Caspian sea level fluctuations reasons state that the Caspian sea level is controlled by the climate-induced changes in the sea's water budget. They also concluded that tectonic factors have a very insignificant effect on Caspian sea level fluctuations. Inversely, climatic factors are of primary importance in Caspian sea level variations. During the 20th century, anthropogenic activities such as land use changes and reservoir improvements influenced the Caspian sea level. The main water budget of the Caspian Seas comprise river discharges into the sea, precipitation and evaporation over the Caspian Sea, output to the Karabogaz-Gol Bay, and groundwater influx and outflux. But it should be mentioned that groundwater influx and outflux plays an insignificant role in Caspian sea level fluctuations. And between river discharges, the Volga rivers comprise about 80% of the river discharge and is a key parameter in water balance component of the Caspian Sea. Literature shows past studies focused on the reconstruction of past Caspian sea level fluctuations through building regional climate models and using the outputs from atmosphere-ocean general circulation models. Also, future the Caspian sea level has been predicted using AUGCMs and RCM output by El-Gundi and Giorgi and Renselm et al. Moreover, Roshan et al. Predicted the Caspian sea level by applying a simple statistical model to GCM's outputs. Artificial neural networks have also been employed to improve sea level predictions by Imani et al. An artificial neural network is an established technique with a flexible mathematical structure capable of identifying complex nonlinear relationships between inputs and outputs data based on the brain's physiology. In this study, an artificial neural network approach is used to downscale CANIASM-5 model temperature and precipitation in representative stations over the Volga River basin and the Caspian Sea. In this figure, you can see red dots which indicate mentioned representative stations over the Volga River basin and the Caspian Sea. In other words, in this study, the ANN model was trained in order to acquire higher correlation between Caspian Sea level with temperature and precipitation. The Canadian Air System Model version 5, named CANIASM-5, is a global model developed to simulate historical climate change and variability to make centennial-scale projections of future climate and to produce initialized seasonal and decadal predictions. CANIASM-5 is comprised of three-dimensional atmosphere and ocean general circulation models, a sea ice model, a land surface scheme, and explicit land and ocean carbon cycle models. In this study, we use monthly precipitation and temperature projections and historical data of CANIASM-5. The CMIP6 datasets differ from CMIP5 and CMIP3 datasets in terms of forcing scenarios and carbon emissions. The CMIP6 project employed updated versions of the coupled global climate models, a new start year, and a new set of shared socioeconomic pathways (SSPs) scenarios of concentrations. SSPs are scenarios of projected socioeconomic global changes up to 2100. They are used to derive greenhouse gas emission scenarios with different climate policies. These scenarios are SSP1 sustainability taking green road, SSP2 middle of the road, SSP3 regional rivalry or rocky road, SSP4 inequality or road divided, SSP5 fossil fuel development or taking the highway. In IPCC AR5 featured four representative concentration pathways or RCPs that examine different possible future greenhouse gas emissions. These scenarios RCP 2.6, RCP 4.5, RCP 6.0, RCP 8.5 have a new versions in CMIP6. These updated scenarios are called SSP 1-2.6, SSP 2-4.5, SSP 4-6.0, and SSP 5-8.5, each of which result in similar 2100 radiative forcing levels as their predecessor in AR5. In SSP XY, X represents the SSP and Y represents radiative forcing in 2100. ANN was trained for the period 1900 to 2014. The ANN model's input comprise historical precipitation and temperature monthly data of Canyon 5 in representative stations, and the output is monthly Caspian Sea level in Makhachkala station. The prediction was performed by applying precipitation and temperature of CMIP6 scenarios to train ANN for the period 2015 until 2050. This figure shows observed and modeled past and future Caspian Sea level under different CMIP6 scenarios. Dashed black line indicates observational sea level and solid black line indicates modeled past sea level. Both of them reveal ANN reconstructed well the past Caspian Sea level. Also, this table demonstrates the statistical indices indicate the efficiency of reconstructed Caspian Sea level by ANN. In all training, validating, and testing periods, the high value of correlation and low value of RMSE prove the excellent performance of ANN in producing the Caspian Sea level. It is observed that, considering the outputs of different climate change scenarios, the Caspian Sea level will fluctuate between -28 meters and -26 meters due to different climate change scenarios until 2050. Thank you for your attention. I'd be glad to answer any questions you might have.